The next parameter for a two-port network is Y parameters. Y parameters are known as short circuit admittance parameters as well. Right. To define Y parameters, the port currents are expressed in terms of port voltages by these two equations. I1, I2 is equals to Y11, Y12, Y21, Y22 matrix into this column vector V1, V2. So these Y's are the Y parameters of the port network. So if I express this matrix equation in the form of algebraic equations, then it becomes I1 is equals to Y11 V1 plus Y12 V2, and I2 is equals to Y21 V1 plus Y22 V2. Now what we do is that while we found out Z parameters, we successively made these vector variables 0, and we define these four parameters. Similarly, here also in Z parameter this vector was current vector, and in Y parameter these vectors are voltage. This vector is a voltage vector. So we have to make simultaneously make each of V1 and V2 is equals to 0, and we have to find out the values of Y parameters in terms of port voltage and port currents. Now when V2 is equals to 0, that means when port 2 is short circuited, V2 is equals to 0 means port 2 is short circuited. Then what we will get, V2 is equals to 0 means I1 by V1 is equals to Y11, I2 by V1 is equals to Y21. If I put V2 is equals to 0 in these two equations. So I1 by V1, what is it? This is actually admittance. So these both of these quantities are involve input port. Involves the input port. So I1 by V1 is the input driving admittance with port 2 shorted. Similarly, Y12 is Y21 is equals to I2 by V2. I2 by V2 is forward transfer admittance with port 2 shorted, because this is also admittance I by V. If you notice that yesterday while explaining Z parameters, I said that the suffix of the numerator variable and the suffix of the denominator variable defines the suffix of this parameter. It is exactly following the same rule. 1 means both the numerator and denominator variables have their suffix 1. 2 means the numerator variable has the suffix 2 and the denominator variable is having a suffix 1. So it is following that rule. It is a thumb rule. It is you can remember it so that you can check your definition is correct or not. Similarly, when port 1 is short circuited, that is when V1 is equals to 0, if you put V1 equals to 0, then I1 by V2 is equals to Y12 and I2 by V2 is equals to Y22. So I1 by V1 is equals to Y12. So again this is 1, 2 and this is 2, 2. So this is defined as reverse transfer admittance with port 1 shorted, and this is defined as output driving point admittance, because both of these quantities involve the current and the voltage of the output terminal, the output port rather. So it is the output driving point admittance with port 1 shorted. And how forward and reverse quantities are defined? It is defined with the quantity that appears in the denominator. If the quantity in the denominator is that of port 1, then it is forward transfer, and if it is a quantity that involves a variable of port 2, then it is reverse transfer. If you remember this, in Z parameter also, see, the denominator quantity is involves port 2, so it is reverse transfer. And when the denominator quantity involves port 1, a quantity of port 1, then it is forward transfer, right? Transfer means because it involves two variables, one of port 1 and one of port 2. So you transfer something from port 1 to port 2 or from port 2 to port 1. It just signifies that thing, right? So this is how Y parameters are defined. And now again in the similar manner we find out the condition for reciprocity. I have written these equations again. I1 is equals to y11 v1 plus y12 v2, and I2 is equals to this, just to deduce the condition for reciprocity. Here condition for reciprocity was very simple. If you remember how we have arrived at the condition of reciprocity, condition for reciprocity in case of Z parameters, the same method will be followed for all the networks, for all the parameters involving two-port network. That is what in one case the voltage source will be connected at port 1 and port 2 will be shorted. Again interchanging the port 2 will be shorted, and we will find out the response of port 2 due to the voltage source at port 1. So then again we will interchange the position of the voltage source, and we will connect it to port 2, and as a result the response at port 1 will be observed, will be measured, and the response to excitation will be same if the circuit is reciprocal. So that is how we will measure it. That means response to excitation, that means I2 dashed by Vs and I1 dashed by Vs, they will, if they are equal, these ratios are equal, then the network will be said to be reciprocal. So exactly in the same manner as we did in Z transform, when a voltage source Vs is connected at port 1 and port 2 is short circuited, what happens is that I2 is negative of I2 dashed, and V1 is equals to Vs, and V2 is equals to 0, and I1 is equals to I1, right? So from equation 2, V1 equals to Vs, V2 is equals to 0. So what I will get, I2 and I2 is equals to minus I2 dashed. So minus I2 dashed by Vs will be equals to Y21, because V1 is equals to Vs, I2 dashed is equals to minus I2, V2 is equals to 0, means I2 dashed minus I2 dashed by Vs is equals to Y21. So that is written, I2 dashed by Vs is equals to minus Y21. Again for this case, when the source and the excitation are interchanged, then V2 is equals to Vs, V1 is equals to 0, and I1 is equals to minus I1 dashed. So if I put it in this equation, V2 is equals to Vs, V1 is equals to 0, I1 is equals to minus I1 dash, then minus I1 dash by Vs will be equals to Y12. See, minus I1 dash is equals to Y12 Vs, that means I1 dash by Vs is equals to minus Y12. And network, for network to be reciprocal, this ratio ratio of the volt excitation response to the excitation will be equal. So I2 dashed by Vs should be equal to I1 dashed by Vs. So that implies minus of y21 will be equals to minus of y12. So y21 is equals to y12 is equals to y21. That is the condition for reciprocity in terms of y parameters or admittance parameters, right? And now the condition for symmetry. How we arrive at the condition for symmetry in z parameters? That is, the voltage source will be connected at port 1 and port 2 will be open. So V1 is equals to Vs and I2 will be equals to 0. So V1 is equals to Vs and I2 will be equals to 0. So if I put it there, so this will be, and the V1 is equal, port 2 is open. So port 2 is open.